Hey, Miss Marion here. So we're actually doing Unit 1, Lesson 1 and 2. So make sure you have a workbook. If not, you print that information off. And so here's our learning targets and success criteria. So our learning target, or targets, is I'm learning about puzzles and learning about hangers. And in our success criteria, I'll know when I've got it when I can solve puzzle problems using diagrams and hangers, equations, and other representations. So we're kind of going into this equation unit, and we're going to be talking about different things for today to go ahead and do that. All right, so let's go ahead and turn to page 2. Here's our warm-up. We write down one thing you notice and one thing that you wonder. So make sure you write that out. You're going to go, I notice that, fill in the blank, and then I wonder, and then also fill in the blank. So write this on page 2. So pause, write it down on page 2, and then come back to me. All right, so some of you may be like, well, I noticed that there are a couple of colored lines and one black line. I noticed that there's a green line. I noticed that there was a red line. I noticed that there's a blue line. And then some of them can wonder is like, what is the black line for? Why do we have all these different things? What does this represent? And so this is helping us kind of start what we're going to be going into as far as learning for today. So here's an example of what our notice and wonder stuff could actually represent. And so notice how we could say that somebody earned $9 for helping a neighbor. Then they earned $7 for doing chores. But then they owe somebody else $4. And then this could be the total altogether. So here is owing somebody else $4. But you gained $7 and $9, and then put that all together, then I would have $12 total. So notice how there are many different ways to represent different expressions and equations of different situations, and that's what we're going to be looking in today as far as understanding all of that. Alrighty, let's jump into it. Activity 1 says solve each problem showing your thinking, organize it so you can be followed by others. So A, the temperature was very cold. Then the temperature doubled. Then the temperature dropped by 10 degrees. Then the temperature increased by 40. The temperature is now 16 degrees. What was the starting temperature? So go ahead and put that together somehow as for your thought process, showing how you would actually answer that. Put that together, and pause this, put that together, and then come back to me. All right, so I'm going to go ahead and go through this. And so we have the temperature is very cold. And do I know that temperature? I don't. And so, what could I do to kind of show that? I'm going to put a variable in. And I'm going to put M because I like it for Marion. And then it says then a temperature doubled. Okay, so how to write doubled the temperature, which I don't know. And I used M as the variable. I'm going to say 2M. Then it says the temperature dropped by 10 degrees. Dropped. So that would kind of be like minus. And then we have 10 degrees. So minus 10. And then it says the temperature increased by 40. So increased is adding. So we can do add 40. And then now they say that temperature is 16. So is and math is equal. And then we have that 16. So we can say equals 16. Okay. So I'm going to look at this negative 10, positive 40. Let's put it together. And we would have 2M. Put the negative 10, positive 40 together. That's positive 30. Eventually it's going to equal 16. Well, I know from last year, we actually solved these kind of things. So from last year, I'm going to go ahead and I'm going to do PEMDAS backwards. So I see addition, so that means I'm going to subtract. Right. And then we have 16 minus 30. So let's grab our calculator. Let's do 16 minus 30. 30. Oh, that's negative 14. And I still have 2m. So we can either think about it, what number multiplied by 2 makes negative 14, or these two are multiplying, so then I'm going to divide by 2. So then my original number is 7. So this is a way of going ahead and solving this system, or this equation, or following this story. All right, so let's look at activity 1, but B. It says, Lynn ran twice as far as Diego. Diego ran 300 meters further than Jada. Jada ran a third the distance of Noah, and Noah ran 1,200 meters. And then how far did Lynn run? So what I want you to do is, again, we're going to solve this puzzle, show your thinking, how did you figure it out, and then be able to go ahead and explain it to somebody else. So pause this, go through this, answer it, and then come back to me. All right, so I like to kind of just write stuff down. That's just me. So Lynn ran twice as Diego. Diego is 300 more than Jada. Jada is a third of Noah. And then Noah is 1,200. So again, let's kind of put this stuff together. So we're trying to figure out how much did Lynn run. And I know it was 2 times Diego. Right? And this is Diego. Well, we know Diego was 300 plus Jada. And then I can take out Jada. And it said Jada was 1/3 Noah. And then I know I can take out Noah, because Noah was 1,200. So all I did is kind of put together what we have. Let's go ahead and let's answer this. So let's do 1/3 times 1,200. So grab your calculator. Let's see, times 1,200. Okay, that's 400. So I still have Lynn is equal to times. We still have our 300. We just found our 400. Okay, and then let's go ahead and 300 plus 400. Oh, that's 700. So I have 700. And then let's move this up. So then 2 times 700 is 1,400 meters. So even though these are puzzles, we can go ahead and put them together different ways to go ahead and answer them. And that's what this whole unit at the beginning is to understand how to solve puzzles and what they actually go ahead and do. All right, so let's turn to page 7. This is part of lesson 2. And notice how we have this picture. And I want you to write down one thing that you notice and then one thing that you wonder. So pause this, write it down. So you need a sentence underneath page 10. And write those down and then come back to me. All right, so I noticed that there are red socks and green and blue socks. Or I noticed that there's one sock that's heavier. Or I noticed that we have hangers and with socks on them. And then I wonder, why are people hanging socks on hangers? I wonder why one of the blue ones is heavier than the other. And this is kind of weird. I do understand. We don't normally hang up our socks on hangers, but this is our way of just kind of explaining in a way equations and how we always have to have them balanced. We can say that the red hangers is balanced, right? Because it's side to side. And we say that the blue hanger is not balanced. There's one that's heavier than the other. And so we're going to use this idea to understand other things in a bit. All right, go ahead and turn to page 11. And on the page 11, it says this picture represents a hanger that is balanced because the weight on each side is the same. Elena takes 2 triangles off of the left side and 3 triangles off of the right side. Will the hanger still be imbalanced, or will it tip to one side? Explain how you know. So you're going to go ahead and answer that question. You want some writing underneath A on page 11, and then come back to me. All right, so the question was asking about 2 triangles on the left and 3 triangles on the right. And the question is, will it still be balanced? And the answer is no. So remember that the weight of a triangle, if I take 2 of them on the left-hand side off, that means I have to take 2 of them on the right-hand side off. I can't just kind of make it teeter-tottered. And we want to make it so it's balanced. So will the hanger still be balanced? No. We need to take the same amount of triangles off on both sides. So this is kind of the thing about a hanger, is that we want to make sure that the hanger stays balanced. So whatever we do to one side of the hanger, we have to go ahead and do it to the other side of the hanger. All right, so using the same picture on page 11, we're going to go ahead and answer the question. This picture represents a hanger that is balanced. It's already balanced because the weight on each side is the same. So if a triangle weighs 1 gram, how much does a square weigh? So I'm going to go ahead and pause this, answer that question, and then go ahead and come back to me. All right, so I'm going to go ahead and I'm going to label some stuff. So it says a triangle weighs 1 gram. So I'm going to put a 1 in all of these. And then it says that a square, I don't know what a square is. So I'm going to put X's in here, because when we don't know something, we'll put variables in there. And let's move this up. So let's remember that a hanger is the same. What do I have on the left-hand side? I have 3 X's. And then I have 2 1s. That is equal to the right-hand side. I have an X. And I have 1, 2, 3, 4, 5 1s. 3, 4, 5. So let's go ahead, and I notice I can take an X from either side off. So like I can kind of take this X off and this X off, right? So I'm going to do that down here. I can take an X off and an X off. So then how many X's do I have on the left-hand side left over? I have 2X. Let's add our 1s together. I have 2. And then on the right-hand side, let's put all my 1s together. 1, 2, 3, 4, 5. Ooh, this is kind of like 7th grade. I can go ahead and solve this. So I want to go ahead and I want to solve this. So I'm going to go ahead and I see addition. So that's PEMDAS backwards, right? So I see addition of 2, and that means I'm going to subtract off 2 from both sides. Then I know that I have 2x. 5 minus 2 is 3. And then 2 and x, I know that that is multiplying. So that means I'm going to divide by 2 on both sides. So grab a calculator, divide it by 2, go 3, divide 2, that's 1.5. So x equals 1.5. So we're going to say a square is 1.5 grams. So we can go ahead and say, okay, we've solved this. Now we know that a square is 1.5 grams. Please understand and know how to do a hanger, because you will be doing this on your quiz later on. And I think there's also some on that test. So make sure you understand what hangers mean and how to answer those. All right, turn to page 14. On page 14, we actually have, all right, so on page 12, this picture actually is not in there, but the question is, it says a triangle weighs 3 grams and a circle weighs 6 grams. Find the weight in the circle in hanger A and the weight of the pentagon in hanger B. So right now we're just doing hanger A. And so a triangle weighs 3 grams and a circle weighs 6 grams. Go ahead and answer this. And I know it's not in your it's not in there in the picture. So you might want to go ahead and write it, or just make sure that you write down how you're doing it. But we're going to go ahead and solve this. So pause it and then come back to me. All right, so again, we're going to say a triangle weighs 3 grams. So a triangle is 3, and our circle is 6. 6, 6, and 6. 6, and then we don't know what the square is. We're going to put X's in those again. I'm going to move this up. So again, we want to combine everything that's on the left-hand side. So I have a 3, 6, 6, an X, and a 6. And then I have 1, 2, 3, 4. So 1, 2, 3, 4, 6, and then also an X. So just kind of like we did before, I know I can take things off on the both sides. So I'm going to take an X off from one side and an X off from another side. And I'm also going to take 6's. So notice how we have like this 6 and this 6. Let's also take those off too. And that will still, so this is kind of what I took off. Of both sides, it will still make it balanced. And then I notice I have a 3 and a 6 and a 6. And then I have 1, 2, 3, 4. Let's go ahead and let's combine things together. So let's grab our calculator. Let's do 3 plus 6 plus 6. That's 15. 1, 2, 3, 4 X's. Ooh, I've done this before in 7th grade. So I have 4 times X. That means I can divide by 4. So grab your calculator. Let's do 15 divided by 4. Press enter. And that's 3.75 equals our X. So we wrote an equation to represent the hanger, and then we went ahead and we solved it. So we're going to say X equals 3.75. So again, we need to understand hangers because we're going to be doing it later on our quiz and also on our test. All right, so our goal today was to go ahead and think about a balanced hanger. A balanced hanger is a way of actually showing equations. So notice here, we don't know these variables, but we have 1A and then 2B's and then 5B's. And then here I have an A and then a 3B. So hangers themselves, as far as what we've been doing with the squares and the triangles, is that we can go ahead and write equations with it, because this whole unit, we're going to be talking about equations and what they actually mean, what they represent, and how to go ahead and do that. So that's our goal for today, is to go ahead and understand hangers and what they represent and how to write equations with them. And that was our goal. So again, our learning target was to learn about puzzles and hangers. And then when we know how to do it, is I can solve a puzzle problem using diagrams and hangers, equations, and other representations. So this was our goal for today. And so if you did not understand that, go back through the video and do it again. All right, so today your practice problems is lesson 2. It's page 14 to 16. We're doing numbers 1, 2, and 3. And yes, you go ahead and put those answers into Canvas. And there we go. Have a good day. Thanks. Bye.